Let's go ahead and take a look at solids, liquids, and gases. These are the three main phases or states of matter. Now, when you define a state of matter, you can do it in many different ways. You can talk about the distance of the molecules from one another, whether they're close or compact or close and able to flow, or very far apart away from each other. You can also talk about the speed of those molecules. Are they moving very, very rapidly? Are they moving very slowly? Are they just vibrating? Today, we're going to take a look at two other properties of solid liquids and gases. This is going to be the shape and the volume. And we're looking on whether that shape changes or whether that volume changes, or whether either one of them stay the same. So let's go ahead and take a look at our solids portion of the lab. In this portion, you have a wood cube and an aluminum cube. And I have two of these cubes right here. I'll go ahead and show them to you. And we're going to basically compare and contrast these two cubes. So what's the easiest thing is to contrast them. So obviously this wood cube is a little bit larger, right? And then the aluminum cube, of course, your material. One is made out of wood, one is a metal. Your colors are definitely different. The wood cube is a tan color. The aluminum cube is more of a silver gray. One has luster. The metallic cube reflects light, where the wood cube does not. So again, there are many others that you could look at as you're defining these by the differences and or similarities, such as the shape. They're both squares or cubes. Again, if there's others that you can think about for these two cubes based on the shape or volume, you can go ahead and record those down in your lab manual as well. All right, so again, we're focusing on two things: the shape and the volume. Remember, the volume is how big is it? How much space does the object take up? So I'm going to do a very simple experiment. It's going to be so basic. You're like, what are you doing, Mr. Clayman? Watch, I'm going to take these two cubes and I'm going to put them into these two beakers. And again, they're in here now. You can kind of see them. There's the aluminum cube. There's the wood cube. All right, did anything happen to these? Did their shape or volume change? And the answer obviously would be no. And why is that? Why are these two exactly the same as they were before? Because solids retain their shape. Okay, they have what's called a definite shape and a definite volume. Now I can break these in half, right? And that's certainly going to change their shape and volume. But that's just that's doing another step. We're talking about just simply moving it from one place to another. Will a solid retain its shape and would retain its volume? So what does this tell us about shape and volume? Solids have a definite shape and a definite volume. Let's go ahead and over to our liquids. In our liquid portion, I actually have three liquids set up right here. Let me kind of rotate this around. And you can see our three different liquids. I have a tall graduated cylinder. I have a flask. The cylinder has 100 milliliters of discolored water in it. The flask has about 250 milliliters of water, and our smaller beaker has 100 milliliters of water. So how would I describe these? Okay. Well, I was looking at it. Again, we're dealing with shape and volume. Coming back to our graduated cylinder, well, the name of the piece of glassware kind of gives off the shape. It's cylindrical, and it's relatively tall compared to the other two. So if I was to describe it, I would say it's a tall cylinder of water. Our beaker, okay, also cylindrical, right? It has that cylinder, but it's a little bit wider. Okay, so it's a wider cylinder, yet shorter cylinder, and that would be our shape, and our volume is at 150. The flask, as I mentioned, 250 milliliters of water. Now, flasks are interesting because they start out wide at the bottom and then they taper up and get more narrower as they go all the way up to the mouth of our flask. So shape is a little bit harder to, yes, it's kind of cylindrical, but it tapers as it goes up. You might have a better word for that than I do. So that would be our different shapes of water. What about the volume? What about the volume? Well, volume is constant. How do I know that? Because if I take this 150 milliliters of water and place it in our flask, that's 250 milliliters of water. My number now is 400 because I went from 250, I added 150. So the amount is exactly the same as it was when it was in here. It went from 150 in here to 150 in here. If I added in my 100 milliliters of water from here, I was at 400, now it's at 500. So when you look at volume of liquids, the volume is what's called definite or constant. Whether the shape now has changed because it takes the shape of whatever container it is in. All right, let's take a look at gases. If we look at gases, I have a couple balloons here. This is a 9-inch balloon, and this is a 12-inch balloon. So you can see slightly bigger. I'm just going to give it a little stretch out, and I'm going to try to put the same volume. It's going to do one breath into each balloon and tie them off. Okay, so tie that off. And then this is the 12-inch balloon, and a little bit bigger to start with. And then the 9-inch balloon, give it the same couple of stretches. And I tried to put the same amount of air in each one. Again, we're going to focus in on shape and volume. All right, so remember the 12-inch balloon right here, and then the 9-inch balloon. So you can see that the shape, they're relatively similar, right? This one here, it's a little bit more rounded than this one, maybe because this one originally was less rounded to begin with. Let me see if I can bring them here. And size looks relatively the same because, again, I tried to put the same amount of air in each balloon. So when you look at balloons, they're holding gases. Now, if I was to put a hole in this balloon and pop it carefully, that's all. Okay, where are all those gases going? Well, all those gases are going in the room. They're spreading out all over the place. So if I stopped it right there, right, now we have just a little bit of air in here, but it's taking the shape of its container. Let it out again. It's all over the place. So gases, for shape and volume, just like liquids, they take the shape of their container. So they're indefinite. And your volume, how big is it? It is going to be as big as the container is going to be. So the indefinite shape and indefinite volume. So those are just some general features and characteristics of liquids, solids, and gases based on shape and volume. Again, if you have any questions, please don't feel that you can't email me. You can email me at any point. Have a great day, everybody.